Good day, sir. Today we're gonna present our project deliverable tools. So my name is Aerl Japhet Baldapan, and this is my fellow members Miguel Francis and Matthew Opiano. So the objective of our study is the user the admin enable quick and easy processing of customer transactions, maintain an accurate record of product stock levels, and provide a history of sales transactions for reporting and analyze. Implement automated process for stock updates and logging using database triggers and procedures. So the scope of our system is to cover the core functionalities of small bakery point of sale, including adding, managing products, processing new sales, viewing sales history, and basic inventory tracking. So the limitations of our system is lack of user authentication and role management, no integration with external payment gateways, limited advanced reporting features beyond the daily report procedure, no support for multiple users concurrently without potential session conflicts. Basic error handling in the front end relies on client-side JavaScript for cart management before sending to the back end. So the logical design. So the business rules is a sale must consist of one or more items. Each sale item must correspond to an existing product. The total amount of sale is the sum of the subtotals of each item. Stock quantity for product decreases when it's sold. Stock update should be logged. Products cannot be deleted if there are associated sales or stock logs. Enforced by foreign keys and potentially handled by deleting the related records first, as implemented. Products with zero stock quantity are not available for sales on POS interface. So this is our ERD model. So the entities in their relationships. So the entities is products, sales items, and stock logs. So the relationships of sales in items are one to many. One sale can have many sales items, and sales items has a foreign key referencing sales. And the products and sales items is one to many. One product can appear in many sales items. Sales items has a foreign key referencing products. And finally, products and stock logs are one to many. One product can have many stock log entries. Stock logs has a foreign key referencing products. Thanks.
So, hello Sir Randy, my name is Matthew Oliver Opiano. So, for our database normalization, so to ensure our database is efficient and avoids redundancy, we apply the three levels, the normalization, which is this one 1NF, next slide please, 2NF, and lastly 3NF. Can you go back to the first slide please? So, let me explain. So each step with examples from our bakery system. So this one, the first normal form, 1 and F, we ensure that each of the columns contains only atomic values. So that means no list or multiple values in a single field. And for example, instead of storing multiple product names in one column like this, product name, bread, cake, muffin, we store them in separate rows like three products name. So bread, cake, muffin, pandesal, chocolate cookies, like that. This ensures the clarity, consistency, and better data management. Next slide, please. So for the 2NF, so our 2NF focuses on removing the partial dependencies. That's when non-key attributes depend only on part of a composite key. So let's say we have a table where the primary key is a combination of the sale ID, as shown there, sale ID, and the product ID, which is next to it. If we include product name in that table, it's wrong because the product name depends only on product ID, not the full key itself. So we separate it into its own products table. This reduces the duplication and keeps data logically grouped. Next slide, please. So for the 3NF, so you can see the transaction date, total amount, payment method, customer name, which is me, Matthew. So for our 3NF, it removes the transitive dependencies. That means no non-key column should depend on another non-key column. So for example, if we have a products table with product ID, which is the primary key, and the product name, and category description, it depends on, in category description, it depends on the category name, not the primary key itself. So we move category info to a separate categories table and link it with the category ID. So this ensures that each table contains only data that is directly related to its primary key, making updates and queries much more efficient. So by applying these three forms of normalization, we ensure that our bakery database is free from unnecessary repetitions. So di na siya bubalik-balik, and it's also easier to update and maintain. And it will be also structured logically for future scalability in the near future.
Um, Hello, Sir Randy. I am Miguel Francis Lee, and I am going to show what triggers are exist in our database. So the triggers are, we have the product update is to log old values before an update or enforce constraints like preventing stock from going below zero. And the after stock update records changes in stock quantity in the stock logs table after a product stock is updated. Before stock update ensures the last updated timestamp on the products table is updated before a stock changes occur. So in our views, we have no views because views could be used to, and we don't really necessarily need to use views. And this is our UI design for our main dashboard and the system. And if the if the user wants to record a sale, and this and the products tab, I mean the products is to list the products, and they can update the name or the category and the price, and we can add the product here. And his sales history is to show how many sales were in all in the history of the system, and we can filter by start date and end date. So, and lastly, our inventory management. So here we can check if the product has low in stock, and if the stock is added, so we can update here. And that is all. Thank you, sir.
Thank, thank you, Sir Randy.